Gravity is one of the most essential forces in the universe, shaping everything from the motion of planets to the way we experience the world around us. It's a force that affects all objects with mass, from the smallest particles to the largest galaxies, and it plays a crucial role in keeping us grounded here on Earth. At its core, gravity is the force of attraction that pulls two objects toward each other. The more massive an object is, the stronger its gravitational pull. For instance, Earth, being incredibly massive, exerts a powerful gravitational force that pulls everything towards its center. This is why we stay on the ground, why objects fall when dropped, and why we feel weight. The force of gravity on Earth accelerates objects at approximately 9.8 meters per second squared, regardless of their mass. This means a rock and a feather, if dropped in a vacuum, would fall at the same rate because gravity doesn't favor heavier objects. But gravity doesn't only affect us on Earth, it also governs the motions of celestial bodies. The reason Earth orbits the Sun and the Moon orbits Earth is due to the gravitational pull each body exerts on the other. These orbits are not random, they are the result of the balance between the object's motion through space and the gravitational pull keeping them in their paths. Without gravity, Earth would drift away from the Sun, and the Moon would fly off into space. Now, gravity is not just important for keeping objects in orbit. It also plays a vital role in shaping the universe. Gravity is responsible for the formation of stars, planets, and galaxies. In the early universe, clouds of gas and dust collapsed under their own gravity, forming the first stars. Over billions of years, these processes continued, creating the complex structure of the universe we see today, from galaxies to galaxy clusters. In space, gravity behaves a bit differently than on Earth. Astronauts aboard the International Space Station experience what is called microgravity, which is often mistakenly referred to as zero gravity. In reality, gravity still pulls on the station and its crew, but the station is constantly falling toward Earth as it orbits. This creates the sensation of weightlessness because everything inside the station, including the astronauts, is in freefall at the same rate. Gravity also has a powerful effect on objects in space. One of the most interesting phenomena is gravitational lensing, where the gravity of massive objects like galaxies bends light from objects behind them. This effect allows scientists to study distant objects in the universe by observing the way their light is distorted as it passes through the gravitational fields of other galaxies or black holes. In addition to these effects, gravity also causes tides on Earth. The gravitational pull of the Moon and, to a lesser extent, the Sun, causes bulges in Earth's oceans, creating high and low tides. These tidal forces are a result of gravity's ability to pull on different parts of Earth's water at varying distances. Albert Einstein's general theory of relativity changed the way we think about gravity. He proposed that gravity is not just a force between two objects but rather a curvature of spacetime caused by mass and energy. Massive objects like stars and planets warp the fabric of space, and this warping is what causes objects to move toward them. This theory was confirmed through experiments, such as observing how light bends around massive objects like the Sun. Gravity is not just a force we experience on Earth, it is the force that shapes the entire universe. It keeps planets in orbit, shapes galaxies, and influences the paths of comets and asteroids. It governs the behavior of everything, from the smallest particles to the largest cosmic structures, and continues to be one of the most important forces in understanding the universe. In conclusion, gravity is much more than a force that keeps us anchored to the ground. It is a fundamental force that affects everything in the universe, from keeping us here on Earth to controlling the movement of planets and stars. By studying gravity, we can uncover the mysteries of the universe, from the birth of stars to the motion of galaxies, helping us better understand our place in the vast cosmos.